Estimating concrete works basically relies on taking volumes. Check out how to estimate a fence here in quantity surveying. The small project to be estimated is a 4-bay fence of 2 meters height and 3 meters span. There is also an embedment of 3 layers. According to the drawing details, the footings are 0.5 by 0.5 by 0.25 meter. There are 5 of them. The columns are 0.2 by 0.2 and the wall footings are sized at 0.2 by 0.5. It is instructed that concrete mix Class B should be used. Masonry uses 5 inches CHB plastered both faces, but the estimation of masonry works is placed in another video. Let's start with the footings. Illustrating the details, the footings are square of 0.5 meters, depth is 0.25, and there are 5 of them. The required volume can be computed as 5 times the length, width, and depth of each. So that is 5 times 0.5 by 0.5 with 0.25 meters, giving 0.3125 cubic meters. Taking an allowance for wastage, note that footings are exposed directly to the soil, so use 10%. Thus, the required volume for footings is 1.1 of 0.3125, and that gives 0.34375 cubic meters. This is the volume we use for the quantities of concrete. Class B mixture uses 7.5 bags of 40 kg cement, so multiplying this factor to the volume of 0.34375 gives 2.578125 bags. Sand has a factor of 0.5, so the required volume comes out as 0.17 cubic meters. Then for gravel, the factor is 1, resulting to 0.34 cubic meters. The next members of the fence are the columns. The plan has detailed columns as 0.2 meters squares. The height of each protrudes 2 meters from the natural grade line, but then there is embedment of 3 layers. Stacking 3 layers of CHB with a standard height of 0.2 meters adds 0.6 meter to the column height, thus giving 2.6 meters total column height. The total volume of the columns is solved like the footings, which is then computed as 5 columns of 0.2 by 0.2 by 2.6. That gives 0.52 cubic meters. Add the wastage allowance, and since columns are created using forms, the additional percentage is just 5. So the total required volume becomes 1.05 of 0.52, giving 0.546 cubic meters. This volume is used for the quantities of components, where cement is computed as 0.546 by 7.5, resulting to 4.095 bags of 40 kg cement. For sand, take 0.546 times 0.5, or that is 0.273 cubic meters. Gravel is taken as 0.546 by 1, which is still 0.546 cubic meters. The last members for concrete works are the wall footings. There are 4 of them from the plan, with width of 0.5 meters and depth of 0.2. The length would have to be computed from the plan, with the standard span of each bay as 3 meters, measured on centers. The length of the wall footing is computed as the clear span between columns. The clear span uses 3 meters less twice of half of each column on both ends. Get 3 meters minus twice of 0.2 divided by 2, which results to 2.8 meters. With the 3 dimensions already known, solve for the volume, which is 4 of 0.2 by 0.5 by 2.8. The wall footing volume is 1.12 cubic meters. Adding the wastage allowance, use 10% for footings, so the required volume is 1.10 by 1.12, giving 1.232 cubic meters. With Class B mix, cement is 1.232 times 7.5, which is 9.24 bags. Sand has 1.232 times 0.5, and that is 0.616 cubic meters. Gravel is 1.232 times 1, which is still 1.232 cubic meters. Now summarize the materials. For cement, footings require 2.58 bags, columns need 4.1 bags, and wall footings 9.24. The total bags required are 15.91, which can be rounded up to 16 bags. For sand, footings need 0.18 cubic meters, columns 0.28, and wall footings 0.62, which can be summed up to 1.06 cubic meters. Since aggregates can be ordered in half cubics, the quantity can then be rounded up to the nearest half, that is 1.5 cubic meters. For gravel, footings require 0.35, columns 0.55, and wall footings 1.24, added together to have 2.12 cubic meters, and rounded up as 2.5 cubic meters.